Welcome to our presentation on the Slipform rig build. This is for the high risk review at the 2 Finsbury Avenue project. Carried out a review of exclusion zones, access and egress into the slipform. Even though a lot of the slipform is manufactured off-site, you still need an area 2 to 3 times the size of the slipform adjacent in order to get the rig assembled, as there are a lot of loose components, flat pack components, which does take up space. So the slab, casting of the slabs and timelines for the build was really important. So we had a phasing of the internals going in, then a lot of the loadout area outside is for external working deck and top deck and then trailing deck. So the teams doing slabs and all the adjacent works needed to understand what was required in order to effectively build the slipform and the timeline required. We engaged quite early with our preferred hoist contractors, and the locations of hoists were very difficult to be placed. They could only be on the ground floor, and we were kicking off on the B1 slab, so they were delayed for the install, but also positioning of it so that not too much of the steel erection, which started very early on this project, would be interfered with. So a lot of work was done with the principal contractor establishing where these positions would be and the connections to walls, etc., because this slipform had quite a few walls that fell away, cells that fell away, walls that had large openings in them. So we were very limited in how you could do it. We chose to use the peri-up system for the emergency egress off the rig. You can see on the slide to the side where the ladder comes off, goes up into the rig. It's constantly built underneath the slipform to make sure that there's always a safe access off the rig should there be an emergency and should the hoist not be working, which would be the primary access. Within the rig itself, we have access between the 3 levels. On the left to the bottom, you can see there is a ladder coming through. It's been shrouded, has a door, a gate, which enables other people not to fall down through the hole. The middle diagram shows that same ladder coming down onto the working deck. We have 1 staircase, top deck to working deck, for people who need to carry materials and have their hands free to carry something because it doesn't work with the ladders. To the middle one again, you see the yellow hatch being one of the most difficult things to manage on a slipform, probably one of the most riskiest items to deal with as well. We had to review machinery and equipment to be used on the rig, the hydraulic systems, which also with quite a lot to be done as far as the hydraulics carrying the crane. Pipeline locations, very important in case you have any blockages. We had to make sure the locations were in line with the staircases. We also reviewed abrasive wheels. Obviously it's a fire risk, and what sort of plant we should use, and we've managed to go away from abrasive wheels and use a guillotine cutting system for anything that's required up there. The Slipform system, which we used on this project, requires the wailings to be welded, so we had to have a proper structural welder on site to mitigate for the risks, eye damage, burns, fire, electrocution, and make sure that our method statements cater for these things, and that the right qualified people are going to be doing the works. We had to review the risks regarding the jacking systems, the hydraulics. Obviously hydraulic oil can have skin damage, part failure. It has a fail to safety system should the actual jacking system fail, so it can't actually have a catastrophic failure. A lot of the parts are fed internally within the system, which is much better than overhanging on the top of the working deck. So a lot of the risks are actually mitigated through that as well. We had to review the pumping and concrete line strategy. size of the rig and the quantity of concrete meant we had to have 2 placing booms, as you can see on the top right hand side. In the sort of pink and green, there was 2 booms up there, as well as the pumps. They could not be placed right next to the slip because of the logistics. Where the screen you can see here actually has changed a few times, in that they were moved in underneath the building eventually. This helped with the steel erection and all the other deliveries to the site. With having 2 placing booms on the rig, obviously we've got 2 pipelines coming up. We had to make sure that the peri-up staircase was adjacent them. Should there be any problems with pipe blockages, etc., we can actually get to the pipes and not lose a whole pipeline, which would probably lose about 5 days on the project, having to take them down, replace, not to mention the cost. This is a typical placing boom arrangement with a scissor system to allow the pipes to be continuously pumping while the rig moves. So this scissor system would close up, allowing the rig to move, and the vertical pipes will be replaced as and when required once the scissor has closed up. So a review had to be taken of the locations, also when to go from low pressure to high pressure, as the west goes up to 109 meters and the east goes up to 167 meters. So we had to keep a close eye on when we had to make sure that systems were put into place, as well as we had to get 2 pumps, new ones, which are electric. So making sure power to those was sufficient and put into the right places for the operations. With regards to the engineering controls, the core lateral setting out and the actual keeping it plumb, there were targets set up. We had very good lasers put in place. The lasers have got a very good tolerance for these tall structures. There was also quality control checks done separately by an internal engineering team, and pre-pour checks done every morning and throughout the day, together with the SRM engineers. This is a video of a previous project we did. Inductions are quite long and there's a lot of information to go into each of them. We've decided to split into the construction of the rig, the operation of slip forming, and alterations and dismantling. So within each of those, a high risk review was carried out, and out of that high risk reviews and all the information coming back, the method statements and risk assessments were put together. In order to have no accidents, we had to get the risk profiles and making sure that control measures were suitable for each of the risks. They were well looked into and that they were mitigated down to an acceptable level. Slip forms are quite noisy places, mainly due to the high frequency pokers requiring the compaction of the concrete. So hearing protection is available at the very bottom before you get to the slip, as well as within different places around the slip form. So it's really important that people adhere to this and protect their hearing, and that it's mandated by the supervision. Embedment plates are pretty heavy items normally. On this project, quite considerably heavy and heavier than normal. We did an exercise checking on all the weights of them, and some of them were up to 245 kilos to be cast into the wharf, and then some of the crane connections to the external were up to 750 kilograms. So a lot of work was done, early engagement with McAlpines, making sure there was holes in the plates. We were able to lift them. The top deck had sufficient places that we could drop these really heavy plates through. So manual handling had to be kept to a minimum, and also only the very small plates were man-handled. Everything else was either by crane or block and tackle. This is an example of risks that were looked at and noted, and what control measures we thought might be the correct ones to add into the risk assessments.